there, children. Gandalf, the Graphing Wizard, here talking to you about slope and rate of change. Now here's a question. What did Gandalf tell a student who was getting an F in math class? You shall not pass!
First vocabulary term is slope or rate of change. That's a fraction or ratio comparing the change along the y-axis to the change along the x-axis between any 2 points on a line. So here you can see we have our red line right here, and we picked 2 points on that line. You could have picked any 2 points on this line, and the slope or rate of change will be the same between those 2 points. How do we determine what the slope or rate of change is? Well, it's the rise over run. What does that mean? Well, the rise is the change along the y-axis between these 2 points. So these 2 points go from a y value of 1 to a y value of 7. So that would be the rise. And then the run would be the change along the x-axis between those 2 points. So the run goes from an x value of 2 to an x value of 8. That would be the run. So the rise over the run then would give you the slope. So the slope here would be from 1 to 7, that would be 6. And then from 2 to 8, that would be 6. Therefore, 6 over 6 would give you a slope of 1. You could also think about it as the change in the dependent variable, which is usually represented by your y-axis, over the change of the independent variable, which is usually represented by your x-axis. So the vertical change over the horizontal change, the change in the y over the change in the x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We'll get into that later. And all of this means the same thing. It's your slope or rate of change. Now there are 4 different types of slopes. The first would be a positive slope. And a positive slope occurs when your function, your graph, is increasing as it's going to the right. So it's going up and to the right. And you can think about it this way. As your x values are increasing, your y values are also increasing. That gives you a positive slope. For example, this line y is equal to x has a positive slope. A negative slope is going to occur when your line goes down and to the right. It occurs when, as your x values are increasing, your y values are decreasing. And for example, we have y is equal to negative 2/3 x plus 2 here. This line has a negative slope. A zero slope is going to occur when you have a horizontal line. For example, y is equal to 4. Anytime you have y equals a number, that's going to give you a horizontal line. And horizontal lines have a zero slope. An undefined slope is going to occur when you have a vertical line. That's when you have a line with an equation, x is equal to a number. So here we have, for example, x is equal to negative 7. This has a undefined slope because it's a vertical line.
What did the Hobbit say when he bumped into the wizard? Saruman, didn't see you there. It's example time.
Now, example 1 says, what is the slope of the line passing through the points negative 2, 3, and 2, 6? So the first thing we're going to do here is we're going to graph those 2 points. So negative 2, 3, the x-coordinate is negative 2, the y-coordinate is 3. So I go over negative 2 on my x-axis, up 3 on my y-axis, and I put a point. Then I'm going to plot the point 2, 6. So I'm going to go over to the right 2 on my x-axis, up 6 on my y-axis, put a point. And since I want the slope of the line passing through those points, I'm going to draw a line through those points. Sweet. Now we don't have a formula yet. We just have a graph. Okay, we'll get to the formula in a second. For right now, with our graph, you can still determine the slope. How do we do that? Well, first, is this slope positive or negative? It's going up and to the right. Because your line is going up and to the right, your y values are increasing as your x values are increasing. You know that this is going to be a positive slope. Whatever we get should be a positive number. Next, how far apart are the y coordinates? So what we're going to do is we're going to figure out, okay, between these 2 points, how far apart are the y coordinates? What is the rise? So we're starting at 3 and we're going up to 6. So that would be 3 units apart. Next, how far apart are the x coordinates? So we're starting at x is equal to negative 2 here, and we're going to go to x is equal to positive 2 here. So the run, the distance between the x coordinates, would be 4. So we have 3 units as the distance between the y coordinates and 4 units as the distance between the x coordinates. Now, how do I figure out slope again? Remember, slope is equal to rise over run. So I'm going to put 3 in my numerator, 4 in my denominator, and since it's positive, it's going to be positive 3/4. And you're done. That's how you figure out slope. Really easy.
Why did they come out with the Hobbit movies? 'Cause the fans were baggins for it. You try.
Okay, so again, we don't have a formula, so what we're going to do is we're going to plot these points. So we have -5, 7. I'm going to go over -5 on my x-axis and up 7 on my y-axis, and I'm going to put a point. And then 1, 2, I'm going to go over 1 on my x-axis and up 2 on my y-axis. I'm going to put a point. I'm going to draw a line going through those points because we want the slope of the line passing through these points. Next, what do I have to do in order to figure out slope? I need to figure out, well, is this a positive slope or a negative slope? Since we're going down into the right, since the y values are decreasing as your x values are increasing, we're going to have a negative slope. Next, how far apart are the y coordinates? We have 1 point here and 1 point here. You want to start left and go right. So I'm going to start here. The rise would be down. We're going from y is equal to 7 to y is equal to 2. So our rise would be from 7 to 2. That would be 5 units. And then our run, how far apart are the x coordinates? So we're going from an x value of -7 to an x value of 1. What's the distance between those two x values? That would be 6 units. Now that we know that, what we can do is we can find our slope. Our slope is just equal to rise over run. So what is the rise? That's 5 units. That's going to go in our numerator. 6 units, that's the run. That's going to go in our denominator. And now, is it positive or negative? It's negative because it's going down and to the right. So we know our slope is going to be -5/6. If you are ever given 2 points, you can always graph it and figure out the rise over the run. Now, we're going to talk about the slope formula, which is something you can do besides having to graph it every single time and figure out the rise over the run. The slope formula, which you're probably going to use from now on, says given 2 points, x1, y 1, and x2, y 2, the slope m is equal to y2 minus y 1 over x2 minus x1. So it's just the change in the y over the change in the x, which is what we were just talking about, the change in the rise over the change in the run. This is what you need to memorize for this class and every other math class you take besides this. Example 2 says, what is the slope of the line passing through these 2 points? We are not going to graph it this time. We're going to use the slope formula. I'll show you how easy it is. So in order to figure out the slope of the line passing through these 2 points, what we're going to do is under each of these points, we're going to write for our first point, x1 and y 1. For our second point, we're going to write x2, y 2. The reason is this is going to show you exactly what to plug in and where to plug it in. So we have our slope formula here. y2 minus y 1 over x2 minus x1 is equal to our slope. So we're going to take our y2. What's y2? That's 6, and we're going to plug it in here. What's y1? That's going to be 3. We're going to plug that in here. What's x2? That's going to be 2. We're going to plug that in here. And what's x1? That's -2. We're going to plug that in here. Done. Now don't get fooled. When you plug in -2 for x1, it's minus -2, which turns into +2. And since 2 plus 2 equals 4 and 6 minus 3 equals 3, we have our slope as 3/4. And you're done. Easy stuff, right? Let's try it again. What is the slope of the line passing through these 2 points? So under our first point, we're going to write x1, y 1. Under our second point, we're going to write x2, y 2. We're then going to write out the slope formula, which is slope m is equal to y2 minus y 1 over x2 minus x1. Now we plug in exactly what you see. Y2 is 5, so we're going to put that here. Y1 is 5, we're going to put that here. -3 is x2, we're going to put that here. And 4 is x1, so we're going to put that here. Now we simplify. What's 5 minus 5? That's going to give you 0. And what's -3 minus 4? Well, -3 minus 4 is the same thing as -3 plus -4, so that'd be -7. Now, what is 0 over -7? That's going to be 0. 0 over a number, any number besides 0, is going to be 0. Now, one important thing to remember here, how did I pick which one to be x1 and y 1 and which one to be x2 and y 2? It doesn't matter. You could have picked this one to be x2 and y 2 and this one to be x1 and y 1, and you would have got the exact same answer. Same thing here. Anytime you have 2 points, you can pick either one to be x1, y 1 or x2, y 2, and you should get the exact same slope.
What do you call a wizard with a 9-iron? Can golf! You try.
Okay, doing the same thing. In order to figure out the slope between 2 points, we first, under our first point, write x1, y 1. Under our second point, we write x2, y 2. Then we'll write out our slope formula. M is equal to y2 minus y 1 over x2 minus x1. We're now going to plug in exactly what you see. What's y2? That's 4. That goes here. What's y1? That's 9. Plug that here. What's x2? That's 4. We plug that here. And what's x1? That's 2. We plug that in here. Now, we just simplify. What's 4 minus 9? That's going to be -5. And what's 4 minus 2? That's going to be 2. So our slope is -5 over 2, or -5 halves, and you're done. For part B, it works the same way. You just need to put under your first point, x sub 1 comma y sub 1, under your second point, x sub 2 comma y sub 2. Now we write out our slope formula, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We then plug in exactly what you see. What's y sub 2? That's 17. That goes here. What's y sub 1? That's 12. That goes here. What's x sub 2? That's negative 4. That goes here. And what's x sub 1? That's also negative 4. That goes here. Now, on the top, 17 minus 12 is going to give you 5. And now, negative 4 minus negative 4 is the same thing as negative 4 plus 4, which these are going to cancel each other out, and you get 0 in your denominator. Anytime you get 0 in your denominator and a number besides 0 in your numerator, you are going to write undefined. This has an undefined slope. And again, doesn't matter which one you choose to be, x sub 1 comma y sub 1 or x sub 2 comma y sub 2. You could have flipped those around. You would have got the exact same slope for each of these. Now let's talk about parallel lines for a second. So here we have two parallel lines. What do you know about the slopes of two parallel lines? Let's calculate the slopes of these two lines. So we pick any 2 points on our first line, A, to find the slope of A. So 2 points on A. There you go. Next, we are going to plug them in the slope formula to figure out what the slope of line A is. So remember, anytime you have 2 points, under the first one, write x sub 1, y sub 1, and then under the second one, you write x sub 2, y sub 2. Now we know exactly what to plug into our slope formula. So for y sub 2, we're going to plug in negative 5. For y sub 1, we're going to plug in 1. For x sub 2, we're going to plug in 1, and then for x sub 1, we're going to plug in negative 2. Now we simplify this. What's negative 5 minus 1? That's the same thing as negative 5 plus negative 1, which is going to be negative 6 in our numerator. And then 1 minus negative 2 is going to be 1 plus 2 in our denominator, which is 3. So we get negative 6 over 3, which is going to be negative 2. And that makes sense because your line is going down to the right, so it should be negative. Now let's find the slope of line B. So we're going to do the same thing here. We're going to pick 2 points on line B, and then we're going to find the slope between those 2 points. So to find the slope between 2 points, we pick one of these points to be x sub 1, y sub 1, and then the other point would be x sub 2, comma y sub 2. Now we're going to take each of those points and plug them into the corresponding spot in the slope formula. So for y sub 2, we're going to plug in 2. For y sub 1, we're going to plug in 6. For x sub 2, we're going to plug in 2. And for x sub 1, we're going to plug in 0. Now what is 2 minus 6? That's going to be negative 4. And then 2 minus 0 is going to be 2. And now what is negative 4 over 2? That's negative 2. Now what do you notice about the two slopes here of our given parallel lines? They're the same. And this is something that is true for all parallel lines. Parallel lines are going to have equal slopes every single time. Memorize that. Now, perpendicular lines work a little bit differently. So to show you how these work, I'm going to find the slope of line R and line S because they are perpendicular. That's what this little red box means. And show you what happens when you have two perpendicular lines. So the slope of line R. We need 2 points on line R. You can pick any 2 points. I'm going to pick these 2. Now to find the slope, I label one of these points x sub 1, comma y sub 1, and the other one x sub 2, comma y sub 2, and plug them into the corresponding spots in the slope formula. So for y sub 2, I'm going to put negative 4. For y sub 1, I'm going to put 0. For x sub 2, I'm going to put 1. For x sub 1, I'm going to put 0. Now I simplify. What's negative 4 minus 0? That's negative 4. What's 1 minus 0? That's 1. And what's negative 4 over 1? Negative 4. So we have found the slope of line R. And that makes sense because it's going down to the right, so it does have a negative slope. Let's check the slope of line S. So we need 2 points on line S. Well, the cool thing is we already have one. This is a point on line R and line S because that's where they intersect. So we have 1 point. Let's pick another one. Now we're going to label them x sub 1, comma y sub 1 and x sub 2, comma y sub 2. You could have done it in either order. You would have got the same thing. Now let's go ahead and plug them into their corresponding spots in the slope formula. For y sub 2, I'm going to plug in negative 3. For y sub 1, I'm going to plug in negative 4. For x sub 2, I'm going to plug in 5. And for x sub 1, I'm going to plug in 1. Now we can simplify what's negative 3 minus negative 4. That's the same thing as negative 3 plus 4, which is going to be 1. And then what's 5 minus 1? That's going to be 4. So I have a slope of negative 4 and a slope of 1/4. So what can we surmise about the slopes of perpendicular lines? Well, it looks like they're the opposite sign, right? This one's negative and this one's positive. And if I were to flip this, I would get 4 over 1 or 4. So it's the reciprocal also. So we could say, and this is true for all perpendicular lines, that the slopes of perpendicular lines are opposite reciprocals. Opposite means you change the sign. Reciprocal means you flip the fraction. Example 3 says, do line A, B, and line CD have parallel or perpendicular slopes? So we're asking if line AB is parallel or perpendicular to line CD. In order to figure that out, we have to find the slopes of each of these lines. And to do that, we're going to use these ordered pairs that we're given. So first, let's find the slope of line AB. How do we do that? Well, we need to use our slope formula. Now we're given points, so we need to label these. Let's label A, x sub 1 comma y sub 1, and B, x sub 2 comma y sub 2. You could have done x sub 2 comma y sub 2 and x sub 1 comma y sub 1, and you would have got the exact same answer. So don't worry about it. So let's plug these in. Y sub 2 is going to be 2. We plug that in here. Y sub 1 is going to be 3. We plug that in here. X sub 2 is negative 3. We plug that in here. And x sub 1 is negative 1. We plug that in here. Now we simplify. What's 2 minus 3? That's negative 1. What's negative 3 minus negative 1? That's negative 3 plus 1, which is negative 2. Now what's negative 1 over negative 2? That's 1/2. Now let's find the slope of line CD. So again, we come over here, we label this x sub 1 comma y sub 1 and x sub 2 comma y sub 2. Again, could have flipped them around, you would have got the same thing. Here, y sub 2, I'm going to plug in 3. Y sub 1, I'm going to plug in negative 4. X sub 2, I'm going to plug in 8. X sub 1, I'm going to plug in negative 6. Now we simplify. What's 3 minus negative 4? That's 3 plus 4, which is 7. And then what's 8 minus negative 6? That's 8 plus 6, that's 14. Now what is 7 over 14 simplified down to? 1/2. Now, what do you see about these two slopes? They are the same. Now, anytime you have two slopes that are the same in two lines, we know that those lines must be parallel. Let's try B. We're going to start by finding the slope of line AB. How do we do that? Well, we need to use our slope formula. Now we're given points, so we need to label these. Let's label A, x sub 1 and y sub 1, and this x sub 2 comma y sub 2. You could have flipped these around. This could have been x sub 2, y sub 2. This could have been x sub 1 comma y sub 1. Would have got the same slope. So now I'm going to plug in 2 for y sub 2. I'm going to plug in negative 3 for y sub 1. I'm going to plug in 0 for x sub 2. I'm going to plug in 1 for x sub 1. Now we simplify. What's 2 minus negative 3? That's the same thing as 2 plus 3. That's 5. And what's 0 minus 1? That's negative 1. What's 5 divided by negative 1? That is negative 5. Cool, we got the slope of line AB. Now, what's the slope of line CD? We go up here, label it. X sub 1 comma y sub 1, x sub 2 comma y sub 2. Could have flipped those, doesn't matter. Here, we plug in 2 for our y sub 2. We plug in 0 for our y sub 1. We plug in 8 for our x sub 2. We plug in negative 2 for our x sub 1. Now we simplify. What's 2 minus 0? That's 2. And what's 8 minus negative 2? That's the same thing as 8 plus 2, so that's 10. What's 2 over 10? That's going to be 1/5. Now the question, are these parallel or perpendicular? Well, they're obviously not parallel because they would have to be equal to be parallel. Since this is negative and this is positive, they are opposite. And since this is 5 and this is 1/5, they are reciprocals. Because they're opposite reciprocals, you can say that these two lines are perpendicular. Now let's do the word problem. It says, given the table, what is the rate of change of the temperature per hour? So we're given this table, the amount of time in hours and the temperature corresponding with those hours. Now the rate of change, what does that mean? It's just asking for the slope. And here it gives you a table, which is a bunch of x values and a bunch of y values. So all you have to do is pick two ordered pairs and find the slope between those 2 points. So what I'm going to do, the rate of change is equal to our change in the y over change in x, or in this case, the change in the temperature over the change in the time, because remember, temperature is our dependent variable because it's on the right, time is our independent variable because it's on the left. So what we're going to do is we're going to plug these in for our given slope formula. How do we do that? Well, we label just like we normally do. This is our first point, 1 comma 45. So we're going to say this is x sub 1, this is y sub 1. This is our second point, 2 comma 47. So I'm going to say this is x sub 2, this is y sub 2. Now we just plug these into the slope formula. 47 is going to go in for y sub 2, 45 is going to go in for y sub 1, 2 is going to go in for x sub 2, 1 is going to go in for x sub 1. Now we simplify. What's 47 minus 45? That's 2. And what's 2 minus 1? That is 1. So we end up getting 2. But you don't write that as your answer. It's a word problem. It says, what is the rate of change of the temperature per hour? Since we got a positive number, our temperature must be increasing. And it's increasing at a rate of 2 degrees Fahrenheit per hour. And that is your final answer.
What do you call a hobbit party? A little get together. You try.
Okay, this says, given the table, what is the rate of change of the hay needed per horse? So we have horses as our independent variable and hay needed as our dependent variable. So what we're going to do is we're going to find the rate of change, which is the change in the y over change in x, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we need to figure out what is our x sub 1, y sub 1, what's our x sub 2, y sub 2. Again, these are just ordered pairs. So this is 2 comma 150. This is 4 comma 300. So what I'm going to do is I'm going to label this x sub 1, y sub 1, and this x sub 2, y sub 2. Now I know exactly exactly what to plug in where. 300 is going to go in for y sub 2, 150 is going to go in for y sub 1, 4 is going to go in for x sub 2, 2 is going to go in for x sub 1. Now we simplify. What's 300 minus 150? That's 150. And what's 4 minus 2? That's 2. We divide these now. What's 150 divided by 2? That's 75. But since it's a word problem, you don't just leave 75 as your answer. What does that even mean? Well, it's asking what is the rate of change of hay needed per horse. So it means that we need 75 pounds of hay per horse. Given the graph down here for part B, what is the rate of change in the price per gallon? This time we're just given a graph and we need to figure out the rate of change. Remember, rate of change is just the slope. So to figure out the slope, all I have to do is figure out y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here's our line. Let's pick 2 points on the line. They give us a nice easy one, 0, 0. Let's take that. And then another one, how about 1, 4? Sweet. Now let's label these. This will be our x sub 1, y sub 1. This will be our x sub 2, y sub 2. So now we plug these into the slope formula. For y sub 2, I'm going to plug in 4. For y sub 1, I'm going to plug in 0. For x sub 2, I'm going to plug in 1. For x sub 1, I plug in 0. We simplify and we end up getting 4 over 1, which is 4. Don't leave this as your answer. What is it asking? It's asking what is the rate of change in price per gallon. So it looks like as the number of gallons increase by 1, the price per gallon increases by 4. So it's going to be the rate of change is $4, an increase of $4 per gallon.